Morning class 9th students. Today we are going to discuss chapter 8, which is motion. We will discuss now graphical representation of motion. The first graph is distance time graph. Here I have shown you two graphs. Look at the graph A. Here the graph between distance and time is a straight line passing through origin. This graph is for uniform motion. So for uniform motion, graph will always be a straight line. And take any 2 point A and B on the graph. Suppose point A corresponds to time t1 and distance x1, and point B corresponds to time t2 and distance x2. Then the ratio BC upon AC, it will give you the velocity of the object. As you can see, I have written here the equation V equal to x2 minus x1 upon t2 minus t1 equal to BC upon AC. So with the help of this graph, we can find out the velocity of the object. Now look at the second graph. It is not a straight line. The graph is a curve. So this is for non-uniform motion where velocity is changing and acceleration is present. So we have two graphs. One is a straight line, which is for uniform motion. Another graph, which is a curve, which is for non-uniform motion. Next we have to discuss is velocity time graph. Look at the first graph. The velocity time graph is a line parallel to time axis. This is for uniform motion where acceleration is 0, so the velocity is constant and the graph is parallel to time axis. Now look at the second graph. The graph between velocity and time, it is a straight line passing through origin. This is for non-uniform motion where velocity is changing but acceleration is constant. Last graph is between velocity and time. Here the graph is not a straight line but it is a curve. This is also for non-uniform motion but for variable acceleration where acceleration is not constant, it is changing with time. Now the area under the velocity time graph, it gives us the displacement of the object. Therefore from the second graph we can find out the displacement, which is equal to S equal to area of A, B, C, D, E. Let me show you the graph again. Here is the graph. The displacement of the object, it will be equal to area of A, B, C, D, E. And we can divide this figure into two parts. One is rectangle and another is triangle. So the displacement will be equal to area of rectangle ABCD plus area of triangle ADE. So as I have shown you the graph, now area of rectangle we can find out AB into BC, that means length into breadth, and area of triangle will be half AD into DE, that means half base into height. Now next is equations of motion. Suppose there is an object and it is moving on a straight line with a constant acceleration A for some time t. Then its initial velocity, final velocity, displacement, acceleration and time, they are related by these three equations. First equation is V equal to U plus AT. Second equation is S equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2AS, where U is initial velocity, that means velocity of the object at t equal to 0. V is the final velocity, that means velocity after time t. And S is the displacement of the object during this time interval t. A is the constant acceleration.